Today, uh, we are going to study queue data structures. So, last couple of session we talked the couple of data structure like array data structures. Then we talk about the list data structure. Then we talk about the stack data structures. Okay, and also we talk about the linked list data structures. So generally, in the Python, uh, we implemented a stack data structure using the list, or you can say array, and similarly we can use the linked list. Similarly, queue is also one popular data structure, and that's implemented maybe using the list, yeah, array you can say. Similarly, you can use the another approach, a linked list as well as. We're going to talk about the first theoretical linked list and then look how we can implement queue data structure in a Python. So if you talk about the theory, what is the queue? Queue is the linear data structure. What do you mean by linear? So generally, two types of data structures. Okay, data structures can be linear and can be non-linear. Non-linear, or you can say linear. So till now, whatever the data structures we study, maybe talk about the array, list, linked list, queue, stack, all are the linear data structures. That means you can traverse, you can visit element one by one by one by one by one. Okay, you can traverse them. And that are some different data structure. Till now, we not talk about the non-linear data structure. That means kind of a tree data structures, or you can say kind of a graph data structures. Okay, so tree and graph are the data structures which are the non-linear. That means in this case, they have a node and node have a maybe two or three child. Okay? Child one, child two. Similarly, child also have a some node and some different child. Okay? Similarly, these childs also have a some node, also have a node, also. So look like a tree data structures. There is some root node. This is a root node, and similarly have a child node, left child, right child. Left. This kind of data structures is known as a non-linear data structures. So till now we have not talked about this tree and graph, but you should aware tree and graphs are the non-linear data structures. And till now what we study array, list, linked list, tag, queue, these are the linear data structures. Okay, and these linear data structures like queue, they follow the principle of first in, first out. In the last data structure stacks, we learn key last in, first out data structure. LIFO structures. Now this is the FIFO principle. First in, first out. That means the elements added first will be removed the first. So look like a this is the queue. Okay, queue. So whatever the first element come here, next element come here, next element come here, next element come here, next element come here. If I'm going to access and receive, so we are getting accessing this first one, then next, then next. So the first come, first out, you can say first in, first out. So real lots of in the places in your school, college, wildlife example, you are go to any ticket counter. The person, this is that's the ticket counter. Okay, the person visit first, the person visit second, the person visit third, the person visit the fourth. So these are the queue. Okay, and the window, the counter is served by the first element. The first persons are served by the first, then the second people, then the third people. In the real example, queue is the same words. you are going to the queue for any places. Okay, so these are the basics. Like we talk first in, first out is the basic principle of the queue. That means what the element first come in the queue, that's also go first. Queue is also the data structures which hold the collections of element, incoming element, multiple elements, right? So someone want to get the element, the which element first come, first stored, first going to the out IO. So these are the some terminology in the queue. Generally talk Enqueue and Dequeue. Enqueue stand by adding element to the end of queue. Okay. Dequeue means removing element from the front of queue. So here is the concept like a front and rear. Okay, so you can say front and rear. These are two terminology you can understand. Let's say this is the queue. Okay, let's say this is the queue. These are the elements in this. Okay, in this queue. So here front and rear. The first, what is the first element is considered as a front, and what are the last element you can consider as a rear. So rear and you can say front. Whenever you are performing any Enqueue operation, you are getting the front element. Whenever you are going to uh, removing, also you are getting the front element. So always you are working on the front elements. Okay, and in lots of inbuilt data structures where you can say these basic property also considered as a, these are the operations or methods you are going to perform, like adding a new element to the queue, or removing and returning the first element from the queue, or removing the first, just returning the first element like a peak. Similarly, you want to check the empty is the queue is empty or not. Maybe you want to find the size of element, number of element in the queue. These are the basics, you can say, operations we can generally uh, implement while the implementing the queue data structures. Okay, so let's talk basic implementation. The first basic implementation using the list data structure. Very simple, very simplest way. Just you can create the queue using the list, and you can just perform the Enqueue and Dequeue operation. Okay, let's do. Here I can create the queue equal to just. So now you created the queue using the just list, and now you can want to perform some like Enqueue. You want to perform, okay, and simply go and put the append and the elements we are appended. You want to dequeue, just perform the queue. First check queue is not empty, then you can get the pop their first elements data, and you can this way Enqueue and Dequeue operation you can perform just using the append methods on the list implementation of your Enqueue, and the pop and specify. You notice pop in the list is the always return the last element. You want to first you specify in the index which index I want to first. In this way you can get that. Even all the operations you can pick you want to implement. That means implement just you want to return the first item. Here I am using the pop so that we can get and remove the data. Here I pick only the return the first value. Just return the value. We're not going to remove the element from here. If you want to check the emptiness, your queue is empty or not, just check, hey, length double equal to 0, that's true or false. You want to implement the size, so size just length is your size. So in this way, the very simplest way you can implement this complete list data structures. Maybe you can put in the class or directly when you can perform. Okay. So here let's check the exam. Test it. Uh, you uh, just say Enqueue. You can put some element. Okay. Enqueue puts element, and maybe you can here add the, you can say define display. Okay, you want to just display the queue. Okay, so you can added the NQ, and you can just say display. Okay, and if you check, you are getting the these two, three, four elements are added. You want to just like DQ. Okay, and after that display, you can just check, hey, DQ, that means the first elements are removed, and now your this. If you check like peak, and after the display, and if you check, notice they are just displaying the front element, but they are not removing. If this still contain the same number of elements. If you want to check, it's a print, maybe is empty. You want to check our queue is empty or not? No, queue is not empty. You want to size, check the size. So all these operations you can very simplified way implement in the queue. Just create one the list, and list this list object already provide the append method for your enqueue. Requeue for dequeue, we have a pop and provide the zero index. They are always written the first element. For peak, just say queue 0% data. You just get data, don't want to remove. And size, just is the length. And all other functions you can simply perform. So implementation of this queue using list is very simple. Just create the list and use the append method for enqueue and use the pop method for the dequeue. So here, whenever say you created the list, you created the list, you created the list. So generally, first if you add element A are going to add here. Okay. So by default, this element known as your front element, or you can say if you only one element, this is your rear element. If you add one more element here, it's become a B. Now this become a rear element. If you add C, again the C element add. Now this become your rear element. D then B. If you say pop 0, that means this A elements are returns here, and these are the removed, and now this is your front again. Again, you say again pop, this B element return here, and then B the removed, and now front become this. This is the way you can implement the queue data structure. And so some are the collections also available in the Python. Instead of you are going to do, just simply say, hey, import uh, queue from this collection. And in this way, you can also perform the same operation like for enqueue, and you can perform by top left for the dequeue. So if you want, so let's from collections and import, okay, let's import just dequeue. Now simply you are going to perform the like dequeue q dot append for appending elements. Okay, let's same elements abc. Okay, That's A, C, and just print. You have to first define the queue. Okay. So how to define the queue? First define your queue equal to DQ. And after that you can perform the that way. In this way you can implement a center. So instead of you writing, you can just use the existing library. If you want to pop, just say uh, pq.left and you can again print. So whenever say pop left, they are removing the first element. Now it's become this. So even generally these are the library we can use, but generally avoid these are the some you can say library available existing if you want to implement or you want to just use them, because they have just specified a specific meaning. Look like the same as your list implementation. So manually you are specified list here, but you can say hey, especially this is a DQ. Okay. And similarly, if you want to more operations you want to perform from the DQ, like just Q like Q, and if you want to check again length, you want to pick just DQ dot zero or just length. This is the simplest approach. All the operations of the queue you can get from this existing library, that is inbuilt library, you can say. And even you can use this DQ library to import some task scheduler work. Let's say you have some task, you can just append, hey, just create one DQ task and put your all the tasks, task 1, task 2, task 3 here, send email, write email, attending a meeting, something, and just do the processing of all tasks. Just pop left, you are getting the first and do process, then second, the process, third, the process. So generally the task scheduler related works. So in the real life, many situation where queue are used, where you want to receiving elements from the different sources. If from real time application you want to do processing, you want to do processing in the order which we receive the data, so you can implement the queue data structure. So that element receive first process, then second receive second process, third receive third process, fourth receive fourth process. The queue is the data structures that hold your data and maintain your first in first out principle. Okay. Even sometime you want to implement like some multi-threading application, you want to thread step collection. Okay, so you can say q dot again one is a q class as well as. Okay, so here is these you want to thread step class. So from collections you can say import imports queues, import just queue directly. You can import queue, queue. Say queue imports queue thread set collections, and you can, if let's check these are the available or not. Queue you, yes. So lots of library also available. You can just use it. Import collection, import queue from the queue. Okay? Import queues from the queue. Okay? Import queue. Okay, from the queues, and after that you can just say queue equal to new queue. Okay, and here you can say queue dot some lots of operation. Maybe you want to put element, put some element, put element, and you want to similarly print every elements. Okay, so this is the way you can get the element. If you want to similarly like uh, get, you can say get, or you can say check is empty or not. They have already inbuilt methods available here. Okay, even you can say print q dot get. So you can get print q dot size. You can say q dot is empty. You want to check is empty. Is empty or tested? Yes. You can. Okay. Okay. Let's stop this. Okay, in this we can get again it is not a false. So you can sometime generally in Python we are not so interested to implement q. uh, Even you can use the existing q library itself or the connections. Here be aware the this library is a thread, so that means at a time only one threads are going to perform the right operation. But collection that's queue, that's not threads, so that's multiple threads can access. So that's the way. Similarly, if you want really you can implement yourself queue, maybe using the linked list. Almost the every data structures you can implement using maybe list, maybe array or linked. Similarly, here we can also implement queue the links. Same concept here. We can first create a node. So notice node have a particular data elements that are holding, and now we can create one class queue, and queue have a 2 pointer, one to the front and another there. So we have a create one class queued, and here you can implement this is the front and this is the rear. And whenever new elements someone going to insert, you can add elements, and what the number you want to add elements, and you can assign this is the my front and this is the my rear. Okay, next element come, this is the next element come, just link here, this is the link, and now this is the my first element array with the same element. Similarly add new element, this is the next and this is the my front again. So always your new elements look like a header, always to the first. So here similar approach we can do. Like here, if you want to enqueue add, so here again you create the whenever come, you create a node. You have already your queue object created. We have a two. One is the your front part, one is your rear part. New node, whenever you can enqueue data, you just created one node, and whatever the data you can put data, and you can say if rear is not null, then you can say this is the first time, the first element. So your front and rear both are pointing to the, your front also pointing to the this, and the rear also pointing to the this. Okay, let's second data come, you put another data, let's put another data 2. Here say new created node. Here this is the not, no, this is not null, both are the pointing something. So you can say rear dot next equal to new node. So what are the rear this dot next, so this the next are pointing to this node. Okay, this node. Okay, and now you can say now rear become the new node. So now this is not rear, so this is not rear, and this is our rear part. Okay, front is the pointing the always. Okay, second times third element come, third elements are added, again link here, and again say hey, this is the my rear part. The rear always pointing to the last element, and your front always pointing to the first element header part. Okay, so previously I'm wrong. So always the uh, whenever you are going to add new elements, our rear going to the pointing to the last elements, and your front always pointing to the first. If someone going to perform the dequeue operation, that case our front part, our rear part, just we return, hey, take the our front part, and front become a next front. Now this is the remove this, return this, and now next time this become a now this is the next front. In this way, you can implement your front Enqueue and Dequeue. Similarly, other operation like is peak and display you can also implement. If you want, you can just go and say, hey, class node, and here you can say whatever the node we have, and here you can say class. I want to create the queue. Okay. And here you can implement your Enqueue, define dequeue. Okay. And similarly, you can define display. P, just define the first element and define the display. This is the, in this way you can just create simply you can just create one node, and here is your front and rear elements. You want to check empty, just check front pointing to null, that means empty or not empty. In queue, just create one node. It is in the first time, it is in the case of first, else always. So this is the logics always you are going to put. Okay. So here, like whenever first times someone add element, this is the our already created our linked list that's have a 2 pointer. One is your front and one is your rear. Okay, the first time, first element, first time, front and rear both point to the same. Whenever next node come, you will say, hey, whatever the rear, whatever this is the rear to next and link to the new node. Okay, and now say the rear is the new node. Now this is the rear become a this node. New node come, again new node come. You can say this is already not none. Rear dot next. Oh, this is the rear pointing to the this, not pointing to this. Rear, hey, this is the next and link to the here. And now not this is the rear part. Now this rear become a this rear part. Similarly, new node come here again. Just say, hey, this is linked to the new, and now your rear become a this. If someone say, hey, I want to dequeue, just go ahead, front pointing to the first element. Hey, go take the front element, and now just return the front value, and just remove them, and now front become a this next front. So now this is the front become a next front. Yes, sir. So always now, if you second time someone dequeue, just return them, and now front become the next front. This is the simplest way we can implement your here enqueue part, and similarly here dequeue part. If you want to test, just you can create the class of queue. Okay, you want to display. Just see enqueue 1 2 3 4. They are 20. Okay. You want to maybe display dequeue, and again display. So your front elements going to the front element going to remove. This is a enqueue, dequeue, and every operations you can implement. The very simplest way. Just understand the basic concepts, and whenever you are implementing yourself, you feel more comfortable the writing code with a Python. Okay, theoretical is okay, and the library also available is okay, but make you feel comfortable with the Python, you have to write the code. For writing code, these are the data structures. uh, If first you know the concept, hey, this is the LIFO concept, this is the FIFO concept, and now you know the concept, and let's think how I can implement, maybe in the array, maybe in the list, maybe the linked list. So here, today we can understand how we can implement queue data structure. Queue is just like our simple one queue, and whatever the elements we are going to add, they are always going to the add at the last, 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 add the last. So here, whenever you are adding element, this is known as your enqueue. Enqueue. Whenever you are removing element, getting element, this is the DQ. This two. The two pointer here also. One pointer is known as a front pointer. One pointer is the rear pointer. Rear always pointing to the last element. Front always pointing to the first element. Whenever you are going to add new element, whatever the your rear part, just link to the new one. Whatever you are going to remove, get element, always the first front part the return the element to. And this way you just write the code, implement them. So you can implement your enqueue, you can implement your dequeue, implement your check the size, is emptiness, even you want to clear, you want to display, all the operation you can implement using a simple, maybe linked list, maybe array, maybe list. As if a good part, the already Python have a library exists. If you want, you can just use the existing library to use the link list or array implementation of the queue. So that is the point for the today I want to convey. I hope this information is helpful for you.